Hello there, and welcome to the Sleep with Science channel, where tonight, we're going to take you somewhere most minds never truly go, not just into space, but into the silence between everything that has ever existed, and ask the question that has quietly haunted every astronomer, every physicist, every philosopher who has ever tilted their head toward a star-filled sky and felt, just for a moment, something vast and wordless pressing back against them from the other side of the dark. Get comfortable now. Let your body sink into wherever you are resting. Let your shoulders fall. Let your jaw loosen. Let your breath come slowly, naturally, without effort. Because what we're about to explore together tonight isn't something you rush toward. It's something you allow to arrive. It's something that finds you, the way darkness finds a room when the last light is finally turned off, completely, and all at once, and somehow more beautiful than you expected. Tonight, we begin with emptiness. Not the emptiness of a quiet room, or the stillness of a sleeping house, or even the deep and comfortable silence of a long, undisturbed night. We're talking about something so much larger than that. Something so incomprehensibly vast that the human brain, even at its most focused and most brilliant, can only ever hold the smallest corner of it before the rest spills away like water through open fingers. We are talking about the emptiness of the universe itself. And here is the first thing you need to truly feel, not just understand, but feel somewhere deep beneath thought, somewhere in the part of you that still understands things without language. The universe is almost entirely nothing. Not mostly nothing. Not largely empty. Almost entirely, overwhelmingly, breathtakingly nothing. The stars you see when you step outside on a clear night, those brilliant ancient points of silver light scattered across the dark like embers from a fire older than imagination, they are the exception. They are the anomaly. They are the rare and fragile accident in an ocean of void so absolute that if the universe were the size of the Earth itself, all the matter in it, every star, every planet, every moon, every asteroid, every comet, every grain of cosmic dust, every atom of every living thing that has ever drawn breath on every world that might exist across 100 billion galaxies, all of it, compressed together, would be smaller than a single grain of sand sitting alone on an endless, lightless beach. Breathe that in slowly. A grain of sand. On a beach that stretches forever. In every direction. Without light. The nearest star to our own sun, a gentle red dwarf known as Proxima Centauri, sits approximately 4.24 light-years away from us. That number, 4.24 light-years, sounds almost manageable when you first hear it. A handful of years. A short sentence. But a light-year is the distance light itself travels in a full year, moving at 186,000 miles every single second. If you were to board the fastest spacecraft humanity has ever launched, the Voyager 1 probe, which has been traveling continuously since 1977 and is now the most distant human-made object in existence, and you pointed it directly toward Proxima Centauri, you would arrive in approximately 73,000 years. Generations beyond counting. Civilizations rising and falling. The entire recorded span of human history, lived again and again and again, 36 times over, just to reach the closest thing to a neighbor our solar system has ever known. And between here and there, nothing. An almost perfect, almost total, almost sacred nothing. No warmth. No sound. No light except the cold, distant, ancient photons racing past from stars too far away to comfort you. No friction. No weather. No gravity strong enough to feel. Just distance, pure and silent and immense, stretching in every direction simultaneously, with no center and no edge and no preference for anything at all. This is the universe we live inside. This is the home our pale blue world drifts through at 67,000 miles per hour, orbiting a star that is itself moving at 514,000 miles per hour around the center of a galaxy that contains somewhere between 200 billion and 400 billion other stars, most of them with their own worlds, their own silences, their own impossible distances between them and everything else. And yet, when you look up at the night sky from somewhere truly dark, somewhere away from the cities and the streetlights and the familiar warmth of human noise, you don't see emptiness. You see abundance. You see a canvas so thick with light that ancient peoples drew shapes between the stars just to make the abundance feel intimate, just to find a story inside the overwhelming, just to reach toward something that seemed to want to be known. There is a reason you feel that pull. There is a reason the night sky, for as long as human beings have had the ability to wonder, has made us feel simultaneously small and significant. Made us feel both lost and somehow, mysteriously, exactly where we are supposed to be. That reason is older than the Earth. It is older than our sun. It is woven into the very structure of the cosmos, into the physics of how matter and energy and space itself behave at the largest scales we can measure, and it begins with a question so quiet and so immense that most people spend their entire lives never pausing long enough to truly hear it. Why is the universe so empty? Not just empty in the way a desert is empty, or the way a winter sky is empty, or the way a house feels empty after someone you love has left it. But empty in a way that feels almost deliberate. Empty in a way that, the longer you sit with it, the longer you allow the true scale of it to rest against your mind without flinching, begins to feel less like a neutral fact of nature and more like an answer to a question nobody remembers asking. Empty in a way that feels, if you are brave enough to follow the thought all the way to its end, terrifying. But we are not rushing toward the terror tonight. Tonight, we are approaching it the way you approach the edge of something very high and very beautiful, slowly, carefully, with full awareness of every step, letting the view expand gradually so that your mind has time to adjust, time to absorb, time to find its footing in a landscape that has no footing to offer. So let us go back further. Let us go back to the beginning, because the emptiness of the universe is not an accident, and it is not a mystery without a history. It has an origin. It has a story. And that story starts in a place and a moment so extreme, so incomprehensibly different from anything in our everyday experience, that the only honest thing to say about it is that our language was never built to describe it, and our imaginations were never designed to contain it, and yet here we are, two small conscious minds, yours and mine, reaching toward it anyway, the way a hand reaches toward warmth without being told to. Approximately 13.8 billion years ago, everything that exists, all the matter, all the energy, all the space, all the time, every atom that has ever been part of a star or a stone or a living cell, every photon of light that has ever traveled across the darkness, every force and every field and every dimension of reality we can measure and several we cannot, all of it existed in a single point. Not a point floating inside empty space. There was no empty space. Not a point existing within time. There was no time. Just a point that was everything, impossibly dense, impossibly hot, containing within it the complete and total sum of all that would ever be, compressed beyond any scale our physics can fully describe, waiting at the threshold of a moment that was not yet a moment, on the edge of a beginning that had no before. And then it expanded. We call it the Big Bang, though that name does it a profound injustice. There was no bang. Sound requires a medium to travel through, and in that first instant, there was no medium, no space for pressure waves to move across, nothing for an explosion to explode into. It was not an explosion at all. It was an expansion. It was space itself being born and stretching outward in every direction simultaneously, carrying everything with it, not like shrapnel flying away from a center, but like the surface of a balloon being inflated, every point moving away from every other point, with no single origin and no single edge, just expansion, pure and total and ongoing, continuing even now as you lie here breathing slowly in the dark. In the first fractions of a second, the universe was unimaginably small and unimaginably hot. Temperatures so extreme that the four fundamental forces of nature, gravity, electromagnetism, and the two nuclear forces that govern the behavior of atoms, had not yet separated from one another. They existed as a single unified force, a oneness at the heart of physics that scientists have spent decades trying to mathematically reconstruct, chasing the equations that might describe that first perfect instant when everything was still everything else and nothing had yet become distinct. As the universe expanded, it cooled. And as it cooled, the forces separated. Gravity peeled away first, becoming its own distinct thing, reaching out across space with its patient, invisible pull. The other forces followed, each one crystallizing out of the original unity like frost forming on a window, beautiful, structured, irreversible. Particles began to form. Quarks emerged from the cooling plasma and bound together into protons and neutrons. Electrons appeared. The universe, still unimaginably young, still impossibly hot by any standard we know, was filling with the raw ingredients of matter for the very first time. But here is where the story takes its first quiet turn toward strangeness. Here is where the first seeds of the emptiness we are exploring tonight were planted. Because when matter formed in those early moments, it did not form alone. For every particle of matter that came into existence, a corresponding particle of antimatter was created alongside it. Equal and opposite. Mirror images of one another at the most fundamental level of reality. And when matter and antimatter meet, they annihilate each other completely, converting entirely back into pure energy, leaving nothing behind. No mass. No substance. Nothing but light. If the universe had been perfectly symmetrical in those first moments, if matter and antimatter had formed in exactly equal numbers the way the equations suggested they should, then everything would have annihilated everything else, and the universe would have been left with nothing but a sea of light and nothing more. No stars. No planets. No galaxies spiraling slowly through the dark. No molecules, no chemistry, no biology, no consciousness sitting quietly in a darkened room wondering how any of this came to be. Just light, traveling endlessly through an empty and eternal void, warming nothing, touching nothing, meaning nothing, forever. But that is not what happened. And the reason it did not happen is one of the most profound and unsettling mysteries in all of physics. A mystery that sits at the very foundation of our existence and still, after decades of the most sophisticated scientific investigation humanity has ever undertaken, does not have a complete and satisfying answer. For reasons that remain only partially understood, the early universe was not perfectly symmetrical. Matter and antimatter did not form in exactly equal numbers. There was a slight imbalance. A tiny, almost unimaginable asymmetry baked into the earliest moments of creation. For every billion particles of antimatter that formed in those first fractions of a second, there were 1,000,000,001 particles of matter. One extra particle. 1 in a billion. That is the margin by which existence won. That is the slender, almost impossibly thin thread by which everything you have ever seen or touched or loved or known was allowed to survive the annihilation that should have consumed it all. The billion matched pairs destroyed each other, as physics demanded they must. But that single extra particle of matter, that one lonely survivor in every billion, had nothing left to annihilate with. And so it remained. And those survivors, scattered across the cooling, expanding universe in numbers still so vast the mind cannot hold them, became the building blocks of everything. Every star in the night sky is made of survivor matter. Every planet, every moon, every mountain and ocean and living cell. Your body, in its entirety, every atom of carbon and oxygen and hydrogen and iron that makes you exactly who you are, is assembled from the remnants of that ancient asymmetry. You are here because of a 1 in a billion imbalance in the very first moments of time. You are the universe's rounding error. And you are, by any measure, miraculous. But now, hold that thought gently, the way you might hold something very small and very fragile, and let us look at what that asymmetry also created. Because when a billion particles of matter and a billion particles of antimatter annihilated each other for every single survivor, they released energy. Enormous, universe-filling quantities of energy in the form of photons, particles of light. The universe in its infancy was not dark. It was a blazing, opaque, ferociously bright plasma, so dense with energy that light could not travel more than a tiny distance before being absorbed and re-emitted, trapped in a constant churning brilliance that filled every point in space equally and completely. For 380,000 years, the universe existed in this state. Not 380,000 years as a brief prologue to something greater. 380,000 years as the entirety of all that had ever happened. The universe at that point was 380,000 years old, which sounds ancient until you remember that the universe is now 13.8 billion years old, meaning that those 380,000 years represent less than 0.03% of all the time that has since passed. A whisper at the beginning of a very long story. And then, as the universe continued to expand and cool, something extraordinary happened. The temperature dropped just enough that electrons, which had been roaming freely through the plasma, were able to slow down sufficiently to be captured by the wandering protons. Atoms formed for the first time. Hydrogen atoms, the simplest possible configuration of matter, one proton and one electron, joined together across the universe in an event cosmologists call recombination, and in that moment, the universe became transparent. Light, no longer constantly intercepted by free electrons, was suddenly free to travel. And it did. It streamed outward in every direction across a universe that had, in that moment, become clear, and it has been traveling ever since. That ancient light, stretched and cooled by 13.8 billion years of universal expansion, still fills the entire cosmos today. We call it the cosmic microwave background radiation, and it is detectable everywhere you point a sensitive enough instrument. It is the oldest light in existence. It is the afterglow of creation itself, the fading warmth of a fire lit before the first stars were born, and it wraps around everything, present in every corner of the universe simultaneously, a whisper of the moment the cosmos first became capable of being seen. When scientists mapped this ancient light in extraordinary detail, they found something that would quietly reshape our understanding of everything. They found that it was almost perfectly uniform. Almost. In every direction, the temperature of the cosmic microwave background was nearly identical, 2.725 degrees above absolute zero, the coldest temperature physics permits, the point at which all molecular motion ceases entirely. But there were tiny variations. Fluctuations so small they required the most sensitive instruments ever built to detect them. Temperature differences of 1 part in 100,000, rippling across the ancient light like the faintest possible texture on an otherwise smooth surface. Those ripples were not random noise. They were not imperfections to be explained away or averaged out of the data. They were the seeds. They were the earliest imprints of a structure that would, over billions of years and under the patient and relentless influence of gravity, grow into something that would come to define the shape of the entire universe. Not the shape of a single galaxy, or a cluster of galaxies, or even a supercluster of galaxies stretching across hundreds of millions of light-years, but the shape of everything. The grand architecture of the cosmos itself, visible only when you pull back far enough that individual galaxies become mere points of light, mere dust motes in a structure so enormous it has no name in any human language that fully captures what it is. We call it the cosmic web. And it is, without question, the largest known structure in the universe. A network of filaments and walls and nodes and voids that spans the observable cosmos in every direction, organizing the matter of the universe into patterns that, when visualized, look startlingly, almost disturbingly, like something organic. Like the network of neurons in a human brain. Like the branching structure of roots beneath a forest floor. Like the tracery of blood vessels in a living eye. The universe, at its largest scale, looks alive. It looks like something that grew. Something that breathed itself into its current form over billions of years of slow, gravitational patience. But before we can understand the web, we need to understand what built it. And what built it was gravity. Gravity is the most familiar force in human experience. It is the first physical law we encounter as children, the hard and immediate teacher that greets us every time we fall. We feel it constantly, in every moment of every waking day, a steady and gentle insistence pulling us toward the center of the earth, holding us against the surface of this spinning world, keeping the atmosphere wrapped around us like a warm blanket against the cold vacuum just above. Gravity is so present, so constant, so woven into the texture of ordinary life that most of us never think of it as remarkable. But gravity is deeply, profoundly remarkable. It is the weakest of the four fundamental forces by an almost incomprehensible margin. The electromagnetic force, which holds atoms together and drives chemistry and biology and every spark of electrical activity in your brain right now, is approximately 10 to the power of 36 times stronger than gravity. That is a 1 followed by 36 zeros. If you held two electrons a centimeter apart, the electromagnetic repulsion between them would be 10 trillion times stronger than the gravitational attraction pulling them together. Gravity, at the scale of individual particles, is essentially irrelevant. It loses every competition at small scales, overwhelmed completely by the other forces. And yet, at large scales, gravity wins everything. Because gravity has one property that none of the other fundamental forces share in the same way. It is universally attractive. Every piece of matter in the universe pulls on every other piece of matter, always, without exception, across any distance, with a force that never turns off and never reverses. Electromagnetism can attract or repel, depending on the charges involved, and those effects tend to cancel out over large scales as positive and negative charges balance each other. But gravity only ever pulls. It accumulates. It compounds. And given enough time and enough matter, it shapes everything. In the very early universe, in the wake of those tiny temperature fluctuations imprinted on the cosmic microwave background, there were regions of space that were very slightly denser than their surroundings. Not dramatically denser. Not visibly different in any way that could have been observed at the time. Just fractionally, almost imperceptibly more concentrated with the raw matter of creation. And gravity, patient and tireless and absolute, began to do what it always does. It pulled. The slightly denser regions attracted more matter from their surroundings. As they gathered more matter, their gravitational pull increased. As their pull increased, they gathered still more matter. A feedback loop, slow at first, almost imperceptibly slow, playing out across millions and then hundreds of millions of years as the universe continued to expand and cool around it. The denser regions grew denser. The less dense regions grew emptier. Matter flowed, like water finding channels in stone, along the invisible pathways carved by gravity's patient insistence, collecting in the nodes and filaments of what would eventually become the cosmic web. And the spaces in between. The spaces that matter flowed away from. The regions that lost the gravitational competition and found themselves progressively abandoned by the matter drifting toward denser neighborhoods. Those spaces grew. They grew larger and emptier with every passing million years, as gravity continued to drain them of whatever matter remained, pulling it outward toward the filaments and walls and galaxy clusters forming along the edges. These spaces are called cosmic voids, and they are, in the truest and most absolute sense of the word, empty. Not the comfortable emptiness of a quiet room. Not the poetic emptiness of a starless patch of sky seen from a city park. Real emptiness. Voids that stretch across hundreds of millions of light-years in every direction, containing almost nothing. No galaxies. No gas clouds. No significant concentrations of dust or dark matter. Just space, pure and cold and ancient, expanding slowly in the dark, growing larger with every passing moment as the universe itself continues to stretch. The largest known void in the observable universe is called the Boötes void. It spans approximately 330 million light-years across. To cross it at the speed of light, traveling at 186,000 miles per second without stopping, without slowing, would take 330 million years. Not 330 million miles. Not 330 million kilometers. Years. Years at the speed of light. Years traveling at a velocity so incomprehensible that, in a single second, you would have already crossed the distance between New York and Los Angeles more than 60 times over. And still, after 330 million of those seconds stretched into years, you would only just be emerging from the other side of this one void. This one hole in the fabric of the cosmic web. One of many. Let that settle somewhere quiet inside you. Because the mind does not process this kind of number the way it processes ordinary distance. It cannot. The human brain evolved to navigate a savanna, to judge the distance between trees, to estimate how far a river might be by the sound of its current moving through the dark. It did not evolve for this. It was never meant to hold a number like 330 million light-years and feel the weight of it accurately. And so we approximate. We reach for metaphors like a person reaching for a handhold on a sheer cliff face, grasping at whatever might slow the fall into the incomprehensible. And yet the Boötes void exists whether we comprehend it or not. It was discovered in 1981, almost by accident, when a team of astronomers conducting a survey of galaxies in that region of the sky found something they were not expecting. Absence. A region of space so conspicuously devoid of galaxies that at first the researchers considered the possibility that their instruments had malfunctioned, that some error in the data had created the illusion of emptiness where there should have been structure. But the instruments had not malfunctioned. The data was not wrong. The void was real. And when subsequent surveys confirmed the finding, when other telescopes turned toward that quiet corner of the constellation Boötes and found the same profound silence, the same unbroken darkness stretching in every direction, the scientific community was left with a structure that challenged some of the prevailing assumptions about how matter had distributed itself in the early universe. Because the Boötes void is, in the language of cosmology, anomalously large. The large-scale structure of the universe, those great filaments and sheets and walls of galaxies connected into a web, produces voids as a natural consequence of gravity's long work. As matter flows toward the denser regions, the spaces between grow thin and then empty. This is expected. This is written into the physics of how structure forms. But the Boötes void is larger than most current models of cosmic evolution would comfortably predict for a universe of this age. For a void of this size to have formed through ordinary gravitational processes alone would have required more time than the universe has yet existed. Which means either our models are incomplete, which they certainly are, in the way that all models of something this vast will always be incomplete, or the Boötes void formed through some combination of processes we do not yet fully understand, perhaps the merging of many smaller voids over billions of years, their boundaries dissolving slowly into one another the way individual shadows merge at dusk into a single unbroken dark. Some astronomers have called it a supervoid. Others have described it more plainly, almost reluctantly, as simply the emptiest known region of space within our observable universe. Within the entire sphere of existence we are capable of seeing from our position here, on this pale and orbiting world, there is no region more thoroughly abandoned than this. If our own Milky Way galaxy were situated somewhere near the center of the Boötes void, our night sky would look different than it does now. Not darker in the way of clouds or seasons. Different in a more permanent and disorienting way. The nearest galaxies would be so distant that for most of human history, even with the telescopes we have built and the surveys we have conducted, we might never have known they existed. The universe, from that vantage point, would have appeared for thousands of years to be nothing but our own galaxy and an empty sky beyond. A single island of light in an ocean with no other shores visible in any direction. It is a strange thing to imagine, and a quietly unsettling one, because the question it raises is not merely about light and distance and the capabilities of telescopes. It is about what we would have believed. What cosmologies would have formed in the minds of creatures looking out from inside that void, searching the darkness for evidence of something beyond themselves, and finding nothing. What conclusions would have been drawn from that absence? How long it might have taken, or whether it ever would have happened at all, to look far enough and long enough to finally see, at the very edge of the observable, the faint and distant glow of a galaxy that existed beyond the rim of the emptiness, proof that the universe extended further than the void, that there was something on the other side of all that nothing. We are fortunate, in a sense that feels almost too large to name, that we live where we do. Embedded in a filament. Surrounded by neighbors. Situated within a galaxy that belongs to a cluster, which belongs to a supercluster, which connects to the broader web in ways we are only now beginning to fully trace and understand. But the Boötes void is still out there, in the direction of that faint northern constellation, expanding even now, its boundaries drifting outward in the slow and patient way that all voids drift, growing incrementally larger with each passing epoch as the universe continues its expansion and the filaments along its edges draw matter further away from its interior. There is no event that will reverse this. No force currently known to physics that will one day cause the Boötes void to fill again, to gather matter back toward its center and rebuild what was never really there to begin with. It will only grow. Quietly, consistently, indifferently. The way all the voids grow. The way emptiness, once established at a cosmic scale, tends to deepen rather than heal. And this is where the story of the universe's large-scale structure becomes something that asks more of us than simple wonder. Because the voids are not anomalies. They are not scars or wounds in the fabric of the cosmos. They are not the places where something went wrong. They are, in the fullest and most precise sense, the natural outcome of everything going exactly as the physics demanded. The universe did not fail to fill these spaces. It chose, in the only way a universe can choose, through the blind and tireless operation of fundamental forces across immeasurable time, to empty them. Gravity gathered matter together in some places and in doing so, necessarily abandoned others. The web formed. The voids formed. And both are expressions of the same underlying order, the same set of initial conditions pressed forward through 13.8 billion years of relentless becoming. There is something in that fact that resists easy comfort. We tend, as a species, to find meaning in fullness, in presence, in the gathering of things toward one another. Cities, families, ecosystems, the dense and tangled richness of a forest floor. We interpret density as vitality, as the sign that something significant is happening. And we are not wrong to feel that way. Life as we know it requires proximity, requires the concentration of elements, the warmth of a nearby star, the presence of a planetary surface where chemistry can repeat itself patiently across millions of generations until something stirs and breathes and eventually looks upward. But the universe does not share this preference. Most of the universe, by volume, is void. If you were to take the entire observable universe and divide it not by the mass it contains, but by the space it occupies, the overwhelming majority of that space would be these great empty regions. The filaments and walls and galaxy clusters, for all their grandeur and complexity, for all the hundreds of billions of galaxies they contain, occupy a relatively thin and lacework fraction of the total volume. The rest is this: darkness, expansion, the cold geometry of voids pressing outward in every direction. We are the exception, not the rule. And the voids are, In a way, the most honest portrait of what the universe actually is. Not the images we return to most often, the Hubble deep fields with their impossible density of galaxies, each one a smear of ancient light packed into a photograph that makes the cosmos appear almost crowded. Those images, beautiful as they are selected for their richness. They point toward the fullest regions of the sky. They are portraits of the exceptions, the places where matter congregated most successfully, where the web is thickest and most elaborate. Point a telescope instead toward the heart of a void and the image is different. Quieter. A handful of faint smudges near the edges if you are fortunate. Otherwise, in the truest exposures, almost nothing. A darkness that does not resolve into galaxies no matter how long you wait or how wide you open the aperture. Just the deep and photographic black of space recorded faithfully, the absence given form by the act of looking. There is a particular kind of vertigo that comes with sitting inside that image, even imaginatively. Because the voids are not distant in the way that individual objects are distant. A star is far away. A galaxy is further. But a void is an environment. It is a region of the universe with an interior and a shape and a duration measured in billions of years. To be inside one would not feel, in any immediate physical sense, different from being anywhere else in space. The darkness between galaxies is darkness whether you are floating near the edge of a filament or drifting through the absolute center of the Boötes void. There are no walls you could press your hand against. No temperature change that would signal a transition from structure to emptiness. The void does not announce itself. It simply is. Defined not by what it contains, but by what, across an almost incomprehensible span of space, it does not. This is perhaps the detail that lingers longest, when the mind finally stops resisting the scale and allows itself to rest inside the concept for a moment. That the universe's most dominant feature is defined entirely by absence. That the thing which occupies the most volume, which has been growing the longest and will continue growing after every star now burning has cooled and gone dark, is not a thing at all. It is the space between things. The silence between notes in a piece of music so slow that entire civilizations could rise and fall between one tone and the next. The voids are not empty of meaning. They are full of a particular kind of truth. One that the universe has been articulating slowly, patiently, across every billion years of its existence, in the only language it knows. The language of physics, of expansion, of matter drawn together here and abandoned there, of forces operating without intention across distances that dwarf every scale of meaning we have ever constructed. And if we are willing to listen to that language, not to translate it into comfort or reassurance, but simply to hear it as it is, what it tells us is this: the universe is mostly nothing, and that nothing is not a temporary condition. It is the destination. This is not a pessimistic statement. It is not intended to diminish the extraordinary improbability of everything that has managed to exist within the web, within the filaments, within the small and gravitationally fortunate regions where matter gathered closely enough to form stars and planets and the long, slow chemistry of living things. The existence of anything at all, against the backdrop of so much void, is a kind of miracle that does not require supernatural explanation to feel genuinely astonishing. The fact that matter clumped, that stars ignited, that some of those stars forged heavier elements in their cores and then scattered those elements across space in their deaths, that some of that scattered material found its way onto the surface of a small and unremarkable planet orbiting an ordinary star near the edge of a spiral galaxy embedded in a filament of the cosmic web, and that on that surface, after billions of years of patient chemistry, something began to ask questions about the darkness it was surrounded by. That is not nothing. That is, by any reasonable measure, everything. But the voids remain, and they will outlast all of it. long after the last star in the observable universe has exhausted its fuel and collapsed or faded, long after the galaxies have darkened and the black holes at their centers have slowly radiated away their mass across timescales that make the current age of the universe seem like an opening breath, the voids will still be here. Still expanding. Still cold. Still defined by the same absence that defines them now. The physics that governs their existence is not the physics of burning and cooling, of nuclear ignition and gravitational collapse. It is simpler and more durable than that. It is the physics of space itself expanding, of dark energy pressing outward without fatigue or limit, of a universe that has more room inside it with every moment that passes and will continue making more room long after there is nothing left to fill it. The voids, in this sense, are the universe's future as much as they are its present. And there is something worth sitting with in that. Something that does not resolve neatly into either despair or wonder, but exists somewhere in the space between them, in the quiet place where the mind has finally exhausted its resistance to the scale of things and simply rests in the presence of what is. The universe is large beyond all useful comprehension. It is mostly empty. The emptiness is growing, and embedded somewhere in the lacework of matter that threads through that emptiness, on a world so small it would not register as a pixel in any image of the large-scale structure. Creatures made of the same atoms that were forged in stars are lying in the dark, breathing slowly, letting the weight of existence press them gently downward into sleep. There is something almost tender in that image, if you hold it at the right distance. But before the mind drifts fully into the dark, there is more to understand about why the universe is structured the way it is. Because the voids and the web did not emerge from chaos. They emerged from something almost impossibly subtle. Something that was present in the very first moments of the universe's existence, in the first fractions of a second after the beginning, when everything that would ever exist was compressed into a space smaller than anything our current language of size was built to describe. In those first moments, the universe was not smooth. This is the detail that changes everything. This is the thread that, when pulled gently, unravels the full picture of why the cosmic web looks the way it does, why matter gathered where it did, why the voids opened where they did, why you are here and the Boötes void is there. The early universe, in the instance after what we call the Big Bang, was almost perfectly uniform. Almost. The operative word. Because threaded through that near uniformity were tiny fluctuations in density. Regions where the distribution of matter and energy was, by an almost unmeasurably small degree, slightly more concentrated than average. And other regions where it was, by that same almost unmeasurably small degree, slightly less. These fluctuations were not random in the way a coin flip is random. They had a structure. A pattern encoded into them by quantum mechanical processes operating at scales so small they exist at the boundary of what physics can currently describe. In the first instance of the universe's existence, the quantum world and the cosmic world were not separate domains. They were the same domain. And the uncertainty that governs particles and fields at the quantum scale left its fingerprints on the distribution of matter across the entire observable universe in a way that would take billions of years to fully express itself. Those fingerprints became the seeds of everything. Every galaxy, every filament, every void, every star that has ever burned, every planet that has ever formed, every ocean that has ever moved under a sun, every moment of awareness that has ever flickered into being on any surface anywhere in the observable universe traces its existence, in an unbroken chain of cause and consequence, back to those first infinitesimal variations in density, to fluctuations so small that if you were to represent the early universe as a perfectly smooth sphere, the variations that seeded all of cosmic structure would not even register as visible texture on its surface. They were whispers, and the universe spent 13 billion years amplifying them into everything we have ever seen or known or wondered about. This is one of the most quietly staggering facts in all of science. Not because it is difficult to state. The statement itself is simple enough. The early universe had tiny density variations, and gravity amplified them over time. That sentence fits comfortably in a single breath. But the implications of it, followed carefully to their ends, open into something that the mind can approach but never fully enter. Because what it means is that the large-scale structure of the universe, those vast filaments and walls and the dark oceans of void between them, is not arbitrary. It is not the result of random chance in any ordinary sense of that phrase. It is the precise and deterministic consequence of quantum events that occurred in the first moments of time, events governed by the deepest laws of physics we have yet uncovered, written into the initial conditions of existence itself. The cosmic web was always going to look roughly like this. Not in every detail. Not with this exact galaxy in this exact position or that particular void shaped precisely as it is. But in its broad character, in its fundamental topology of dense nodes connected by filaments surrounding great empty regions, the universe was always going to produce something like what we observe. The physics demanded it. The quantum fluctuations seeded it. And gravity, patient and unrelenting across billions of years, sculpted it into the structure we now map and measure and lie awake inside of, wondering at the darkness. In the decades since astronomers first began to grasp the large-scale structure of the universe, they have developed increasingly sophisticated tools for studying it. Not just optical telescopes pointed at visible light, but instruments sensitive to radio waves, to the faint glow of microwaves left over from the early universe, to the subtle distortions that gravity creates in the paths of light traveling across billions of light-years. Each of these tools reveals a different layer of the same story. Each one adds texture and depth to the picture of a universe organized at scales that resist ordinary imagination. One of the most important of these tools is something called the cosmic microwave background. It is the afterglow of the Big Bang itself, the light that was released when the universe cooled enough, roughly 380,000 years after the beginning, for electrons and protons to combine into neutral hydrogen atoms for the first time, and for light to finally travel freely through space rather than being constantly scattered by the dense hot plasma that filled everything before that moment. That light has been traveling ever since. Stretched by the expansion of space from the brilliant glow of a hot young universe into the faint microwave radiation that fills the sky in every direction today, detectable not by the eye, but by instruments cooled to within fractions of a degree above absolute zero, listening for the whisper of something that happened before any star had yet formed. And in that whisper, in the extraordinarily precise maps of the cosmic microwave background that modern observatories have produced, the seeds of the cosmic web are visible. Not the web itself, which would take billions of years to grow, but the initial density variations, the slight temperature fluctuations in the early universe that correspond to the slight overdensities that would eventually become the filaments and galaxy clusters, and the slight underdensities that would eventually become the voids. The map of the microwave sky is, in a very real sense, a baby picture of the large-scale structure. A photograph taken before any structure existed, showing only the faint potential for everything that would come. There is something almost unbearably moving about that image, if you allow yourself to feel it. To look at a map of the cosmic microwave background and to know that you are seeing the seeds of every galaxy ever formed, the origins of every void ever measured, the quantum fingerprints of processes that occurred before time had yet settled into the steady rhythm we now experience as seconds and years and lifetimes. That the universe, even in its first moments, carried within it the blueprint of its own large-scale architecture. Not designed, not intended, but encoded. The way the shape of a tree is encoded in the chemistry of a seed before the first root has reached toward water or the first leaf has opened toward light. And encoded within that same blueprint, alongside every filament and wall and galaxy cluster, were the voids. They were always coming. The underdensities were there from the beginning, those regions where quantum fluctuations had left matter fractionally thinner than average, and gravity would spend billions of years honoring that initial condition, drawing matter further away, deepening the emptiness, widening the dark. The voids are not the absence of the universe's plan. They are part of it, as fundamental to the universe's geometry as the walls that surround them, as the filaments that trace their edges, as the galaxies that gathered in their margins like frost forming along the seams of cold glass. The voids were written into the cosmos before the first atom had cooled, before the first star had ignited, before anything we might recognize as structure had yet emerged from the warm, luminous fog of the early universe. They are not mistakes. They are not gaps in a pattern that was supposed to be uniform. They are the pattern. Half of it, perhaps more. The dark half. The quiet half. The half we spent most of human history failing to notice because we were so dazzled by the light. And the light, to be honest, deserves its dazzle. We are creatures of light. Our eyes evolved to catch it, to parse it, to build entire worlds from its variations. Our telescopes are extensions of that ancient hunger, instruments of almost unimaginable sensitivity tuned to gather photons from distances that dissolve all ordinary sense of scale. For most of the history of astronomy, we followed the light. We mapped what shone. We cataloged stars and then galaxies and then clusters of galaxies, and for a long time the map we were building felt like a map of everything. The bright things were the things. The rest was merely background. But the rest was never merely background. The rest was always the majority. And as our maps grew more complete, as the surveys deepened and the catalogs lengthened and the three-dimensional picture of the cosmos began to resolve itself with something approaching clarity, the dark began to speak. Not in light, but in shape. In the shapes left behind by its presence. In the way galaxies avoided certain regions as though warned away. In the spherical symmetry of volumes too large and too regular to be coincidental. In the coherent motion of matter at the edges of the great empty places, drifting ever so slightly outward, as if exhaled. Because that is one of the stranger and more beautiful things we have learned about cosmic voids. They breathe. Not literally, not in any biological sense, but dynamically, in the language of gravity and dark energy and the geometry of expanding space. Matter near the center of a void, in the sparse regions where even the diffuse intergalactic medium grows thin and cold, experiences a net outward push. The local gravitational landscape is dominated by what surrounds the void rather than what is within it. And so particles, gas, the occasional lonely dwarf galaxy, drift slowly toward the walls. The void expands from within as its sparse contents drain toward its edges. It is self-evacuating, self-deepening, a silence that perpetuates itself not through destruction but through simple, patient geometry. And in a universe governed by dark energy, the voids have an ally. The accelerating expansion of space itself preferentially empties the underdense regions. Where gravity wins, in the clusters and filaments, matter compresses, binds, resists the expansion. But in the voids, where gravity is weak and diffuse, the expansion proceeds almost unimpeded. Space stretches more freely in the empty places. The voids grow not only because matter drains from them, but because the fabric they occupy continues to expand while the dense regions hold more or less firm against it. This is part of why the universe's large-scale structure has the particular texture it does, the contrast between the bright, dense walls and the profound, dark interiors. Dark energy is not neutral in this story. It is, in a quiet and persistent way, the patron of emptiness. Astronomers have used this fact in remarkable ways. Because voids expand faster than average, photons traveling through them gain a particular signature, a subtle imprint on the cosmic microwave background called the integrated Sachs-Wolf effect. A photon entering a void falls slightly into a gravitational potential well, then climbs out the other side. But because the void has expanded during the photon's crossing, the well is shallower on exit than it was on entry, and the photon emerges with fractionally more energy than classical expectations would predict. This is a ghost of a kind. A shadow of the void cast not in darkness but in temperature. The faintest possible warmth on the oldest possible canvas. And we have detected it. We have looked at the microwave background and found the thermal whispers of structures we cannot even see, the impressions of supervoids hundreds of millions of light-years across, recorded in the afterglow of the universe's first light. That should stop you for a moment, if you let it. That the emptiness is legible. That the absence leaves a mark. That we live in a universe so thoroughly lawful, so consistently governed by the same principles across every scale and every epoch, that even the places where almost nothing exists tell us precise and quantitative things about the nature of space, about the behavior of energy, about the deep geometry of a cosmos that is still, after nearly 14 billion years, unfolding according to the same rules it has always obeyed. The voids are not beyond measurement. They are not outside the story. They are among the most sensitive instruments we have for probing the fundamental constants of the universe, for testing our models of how space expands and how dark energy behaves, and whether the equations we have written down to describe reality are truly adequate to the task of describing a universe this vast, this old, this strange. That is what the voids offer us, beneath all their poetry and their darkness and their philosophical weight. They offer us leverage. A place to stand outside the ordinary noise of structure and light and measure the cosmos against itself, quietly, in the deep places where almost nothing interferes. And almost nothing is not quite nothing. This is worth dwelling on, because the popular image of a cosmic void, if such an image exists at all in the general imagination, tends toward the absolute. A void, the word suggests, is empty. Truly empty. A volume of space so devoid of content that it approaches the philosophical zero, the nothing that precedes something, the silence before the first sound. But real cosmic voids are not like that. They are underdense, profoundly so by the standards of the surrounding universe, but they are not empty in any absolute sense. They contain gas. Thin, cold, highly diffuse gas, spread so sparsely that it would qualify as an almost perfect vacuum by any laboratory standard on Earth, but present nonetheless. They contain dark matter, smoothed and stretched and depleted but woven still through the fabric of the void in faint, ghostly streams. They contain, occasionally, galaxies. Small ones, mostly. Dwarf galaxies and irregular galaxies, the kinds of systems that formed from modest initial densities and never had access to the rich environment of a filament or wall, the kinds of galaxies that grew up alone, if growing up is a phrase that can be applied to something that has been slowly, quietly evolving for 10 billion years in the loneliest neighborhoods of the known universe. These void galaxies are fascinating objects in their own right, and astronomers who study them have found that they are subtly but consistently different from their counterparts in denser regions. They tend to be bluer, which means younger stars, which means active star formation persisting longer than it does in cluster galaxies, where the dense environment strips away gas and quenches the stellar nurseries over time. They tend to be more isolated, obviously, with fewer interactions, fewer mergers, fewer of the violent collisions that reshape galaxies and trigger the furious bursts of star formation that briefly make certain galaxies among the brightest objects in the universe. The void galaxies evolve more slowly, more quietly, more independently. They are, in a sense, the introverts of the cosmic population, developing at their own pace, undisturbed by the crowded dynamics of the cosmic web's busier neighborhoods. There is something in that image that lingers. A small blue galaxy adrift in the heart of a supervoid, hundreds of millions of light-years from the nearest substantial structure, forming stars at a gentle and unhurried rate, unaware, in any meaningful sense, of the vast emptiness that surrounds it. Its stars rising and burning and dying on their own quiet schedule. Planets, perhaps, orbiting some of those stars. And on one of those planets, in some version of this universe we will never observe, perhaps something looking up. Looking out at a sky even emptier than ours. A night sky in which the nearest galaxy is so remote that it falls beyond the reach of any reasonable instrument, in which the universe presents itself not as the rich tapestry of light we see from our position near the Virgo supercluster, but as a near-perfect darkness punctuated only by the local stars of that lonely galaxy's own body. What would those observers make of the cosmos? What theories would they build? Would they conclude, as some of our own scientists once concluded, that the universe consists of nothing beyond what they can see? That their galaxy is the whole of everything, floating in an eternal and absolute void? They might. And they would be wrong, but not foolishly wrong. They would be wrong in the same way all limited observers are wrong, constrained by the horizon of their instruments and the accident of their position. We are not so different. We sit in a relatively dense region of the universe, embedded in the outskirts of the Virgo supercluster, surrounded by thousands of galaxies within modest distances, and from that position we have constructed a picture of the cosmos that is rich and detailed and almost certainly incomplete in ways we have not yet found the angle to perceive. The void observers would have a different picture, a lonelier picture. But the universe they were trying to describe would be the same universe. The same laws, the same constants, the same dark energy pushing space apart at the same accelerating rate. The emptiness around them would not make the physics different. It would only make the view different. It would only make the silence louder. And the silence of a cosmic void, if we sit with it long enough, begins to feel like more than absence. It begins to feel like a presence of its own. A quality of space that has its own character, its own dynamics, its own slow and patient life. The void is not waiting to be filled. It is not an incompleteness yearning toward resolution. It is a stable feature of a universe that reached its current configuration through billions of years of gravitational choreography, and it will remain, in its broad outlines, for billions more. The filaments will continue to feed the clusters. The walls will continue to mark the boundaries. And the voids will continue to grow, slowly, incrementally, drawing their edges outward as dark energy stretches the space within them and gravity continues its patient work of consolidation at the margins, pulling matter toward the walls even as the walls themselves drift apart on the slow tide of expansion. It is a process without urgency. A process on timescales so vast that the entire history of human civilization, every dynasty and empire and generation of curious minds that has ever looked upward and wondered, occupies less than a single frame in the long, slow film of cosmic evolution. We are brief. The voids are not. And perhaps that is part of what makes them so affecting when we allow ourselves to truly consider them. Not just their size, though the size is genuinely staggering, not just their emptiness, though the emptiness is genuinely profound, but their duration. The great voids of the universe have been emptying for longer than the Earth has existed. The Boötes void, that extraordinary region roughly 300 million light-years across, sitting in the northern sky like a sphere carved from the cosmic web by some patient and indifferent hand, has been deepening since before our solar system had condensed from its rotating disk of gas and dust. Before the first sedimentary rock was laid down on a cooling Earth. Before the first self-replicating molecule began the long, improbable experiment that would eventually produce eyes capable of looking back at it. The void was already old, already vast, already doing what it has always done, which is simply to continue being what it is, the universe's own hollow, patient, expanding dark. The Boötes void deserves a moment of careful attention, because it is one of the structures that genuinely tested our understanding when it was first catalogued in 1981. Robert Kirshner and his colleagues were conducting a redshift survey, mapping the three-dimensional distribution of galaxies in a region of sky, and they found something that the models of that era had difficulty explaining. A roughly spherical region, enormous by any measure, in which galaxies were almost entirely absent. Not sparse. Not merely underdense. Absent. The survey found, in a region where hundreds of galaxies might reasonably have been expected, only a handful. And those few outliers were themselves uncertain, their membership in the void debated. The discovery landed with a weight that the astronomical community spent years processing. How do you get a structure that large? How does the universe evacuate a sphere that size in the time available? The standard models of structure formation, even updated, even refined, found the Boötes void uncomfortably large for the age of the universe. Later surveys softened the picture somewhat. Additional galaxies were found within the boundaries of the void, thin scattered things, not enough to dissolve the emptiness, but enough to bring it into somewhat better agreement with what the models could produce. The Boötes void remained exceptional. It remained a genuine supervoid, one of the largest coherent underdense regions identified in the observable universe. But it was no longer quite the crisis it had initially appeared to be. It settled into the category of extreme but not impossible, a reminder that the universe's statistical distribution of structures contains outliers, that the cosmic web has regions of unusual emptiness just as it has regions of unusual density, and that the map of everything is far too large and far too complex for any single region to be fully representative. Still, the Boötes void has a way of staying with you once you have truly tried to hold its scale in your mind. 300 million light-years. If you were to place our Milky Way galaxy at one edge and attempt to cross to the other side, traveling at the speed of light, the journey would take 300 million years. For context, 300 million years ago on Earth, the first trees were dying in the Devonian forests, the first insects were taking to the air, the continents were assembled into configurations no living eye has ever seen. The light that would have left our galaxy at the beginning of that crossing would only now be arriving at the far wall of the void. Every generation of human civilization that has ever existed, every war and discovery and season of grief and season of wonder, would be compressed into the final fraction of a single second of that journey. And the void would simply be what it is the entire time. Patient, dark, indifferent to the crossing. There is a particular flavor of vertigo that comes from thinking about structures at this scale, and it is different from the ordinary vertigo of astronomical distances. When we talk about the distance to a nearby star, or even to a nearby galaxy, the mind struggles but finds some handhold, some way to acknowledge the number even if it cannot truly feel it. But when we talk about the voids, when we talk about structures that are themselves hundreds of millions of light-years across, structures that exist on the scale of the universe's own architecture rather than on the scale of its individual components, something different happens. The frame of reference dissolves. There is no analogy adequate to the task. No earthly landscape to reach for. The mind arrives at the edge of what metaphor can do and finds only open space on the other side. And perhaps that is appropriate. Perhaps the voids are precisely the places where language should soften and slow, where the narration should become less a sequence of facts and more a kind of quiet accompaniment to something that exceeds description. Because the deepest truth about the cosmic voids is not any single measurement or any particular catalog entry or any one supervoid with a name we have assigned it. The deepest truth is something more like a feeling. A quality of recognition that arrives not through calculation but through something quieter and more instinctive, the way you sometimes understand a piece of music not by analyzing its structure but by simply allowing it to move through you, by being present with it long enough that it begins to resonate with something you did not know was there. The voids resonate like that, if you stay with them. If you allow the scale to settle rather than pushing it away. If you let the darkness be dark rather than rushing to fill it with explanation. And the darkness, when you allow it to be fully itself, reveals something unexpected. It reveals that emptiness is not uniform, that the interior of a cosmic void is not a featureless nothing but a landscape of its own, subtle and graduated, with regions of greater and lesser density that would be invisible against the backdrop of a filament or wall but become apparent when the void's deep quiet serves as the background. The void has texture. Not the bold texture of the cosmic web, not the sharp contrast between cluster and filament and wall, but a whispered texture, a landscape of the nearly nothing, a topography drawn in the faintest possible variations of dark matter density and intergalactic gas temperature. To map it requires instruments of extraordinary sensitivity and patience. But it can be mapped. The silence, examined closely enough, has grain. This is one of the frontiers that modern cosmology is quietly pressing toward. The interiors of voids as laboratories, as clean rooms in which the universe's faint signals can be heard without the overwhelming interference of dense structure. Because the voids are, in a very practical sense, among the quietest places in the observable universe. The gravitational noise that complicates measurements in clusters and filaments, the astrophysical processes that blur and confuse and overwhelm delicate signals, all of that is reduced in the voids, sometimes dramatically. A signal that would be buried in the environment of a supercluster might be detectable in the quiet interior of a supervoid. The emptiness, which might seem like a liability for observation, becomes an asset. The place where nothing happens turns out to be a place where certain things can be seen with unusual clarity. Cosmologists use voids to constrain the equation of state of dark energy, that strange and still poorly understood component that makes up roughly 68% of the universe's total energy content and drives the acceleration of its expansion. The way voids grow, the rate at which they expand, the precise distribution of their sizes and shapes, all of these are sensitive probes of dark energy's behavior. A universe with slightly different dark energy properties would have slightly different voids. The statistics of the void population, the counts and shapes and density profiles of the underdense regions scattered across the observable universe, encode information about the deepest and least understood ingredient in the cosmic recipe. We read the universe's nature in its silences the way a physician reads a patient's health in the spaces between heartbeats. And dark energy is, in its way, as mysterious and as humbling as the voids it helps to shape. We know it exists because the universe is expanding faster than it should be given only the gravitational influence of matter. We know it has a roughly uniform density throughout space, unlike matter, which clusters and clumps under gravity. We know its effects with considerable precision, having measured the expansion history of the universe through multiple independent methods, supernovae and baryon acoustic oscillations, and the cosmic microwave background and the growth of structure itself. But we do not know what it is. We do not have a satisfying physical explanation for why empty space should carry energy, why the vacuum should push rather than simply be neutral, why the universe should be accelerating into its own future at this particular rate and not some other. The theoretical expectation from quantum field theory for the energy density of the vacuum is famously, catastrophically wrong, off from the observed value by somewhere between 50 and 120 orders of magnitude, depending on how the calculation is made. This is sometimes called the worst prediction in the history of physics. The universe is doing something we can measure with great precision and explain with almost none. The voids sit at the intersection of these mysteries. They are shaped by dark energy. They constrain our models of dark energy. They grow through mechanisms we understand mathematically but not physically. They expand in a universe whose expansion is driven by something we have named but not comprehended. And they do all of this with perfect indifference to our confusion, widening on their billion-year timescales while we build our instruments and refine our theories and try, with the limited tools of minds that evolved on a small warm planet, to close the distance between measurement and understanding. There is a particular kind of intellectual humility that cosmology seems designed to produce. Not the false humility of performance, not the reflexive disclaimer that precedes a confident assertion, but the genuine article. The humility that comes from spending time with things that are larger than comprehension and finding that the largeness does not diminish with familiarity. The voids do this. The more carefully you look at them, the more precisely you measure them, the more thoroughly you model their behavior, the more clearly you see that the understanding you have gained is real and valuable and utterly surrounded on all sides by depths that have not yet been sounded. Every answer opens into a larger question. Every measurement reveals a new layer of the unknown. And the unknown, in cosmology, is not a temporary condition waiting to be resolved. It is a permanent feature of the landscape, as fundamental as the voids themselves, as vast as the silence between the stars themselves. And perhaps that is where we must linger for a moment. In the silence. Because the silence of the voids is not merely an absence of sound. Sound, of course, requires a medium, requires molecules pressed against other molecules in waves of compression and release, and there is nothing in the voids to carry it. The silence is something more fundamental than that. It is the silence of having no witness. The silence of spaces that have existed for billions of years without anything to perceive them, without any arrangement of matter sophisticated enough to look up and wonder what it is looking at. We are, as far as we know, among the first things in the observable universe complex enough to ask questions. And the voids predate us by an almost incomprehensible margin. They were already ancient when the first stars ignited. They were already sculpted into their present shapes when the first galaxies began to form along their edges. They have been waiting, in their wordless way, longer than waiting has had any meaning. There is a concept in astronomy called the cosmic web. You may have encountered it before, this image of the universe rendered at its largest scales, luminous filaments of gas and dark matter stretching across hundreds of millions of light years, galaxy clusters glowing at the intersections like cities seen from altitude at night, and between them the voids, the dark volumes, the places where the web is not. The image is genuinely beautiful. It has a quality that transcends mere data visualization. It looks, uncannily, like something organic, like neural tissue, like the branching structure of a river system seen from very far above, like the inside of a sponge. And this resemblance is not coincidental, not exactly. It arises from the same mathematics, the same equations that govern how fluids separate under gravity, how boundaries form between regions of different density, how instability propagates through a medium. These equations are agnostic about scale. They describe the cosmic web, and they describe the capillaries in your hand with the same patient indifference. The universe does not reserve its patterns for the large or the small. It repeats them wherever the conditions allow. But the cosmic web is not static. It has been evolving since the first tiny fluctuations in the density of the early universe, fluctuations so small they were quantum in origin, imprinted when the cosmos was a fraction of a second old, began to grow under the influence of gravity. Dense regions pulled in more matter. They became denser still. The voids, evacuated by this same process, became emptier. What we see today when we map the large-scale structure of the universe is the accumulated result of 13 billion years of this gravitational sorting. Every filament, every cluster, every supervoid carries within its geometry the memory of conditions that existed long before any of the matter it contains had taken its present form. The structure of the universe is a kind of fossil record, and the voids are among the most legible of its entries. Astronomers have, in recent decades, developed increasingly sophisticated techniques for reading that record. By measuring the precise shapes of voids, their depth profiles, the subtle ways in which light passing through them is distorted and shifted, they can extract information about the expansion history of the universe, about the properties of dark energy, about whether the constants of physics have varied over cosmic time. A void is not merely an empty space. It is a laboratory. It is a probe. Its emptiness, paradoxically, is what makes it useful. Because there is so little matter inside a void to complicate the picture, to scatter light and introduce noise, the signal you are looking for, the imprint of the universe's largest-scale dynamics on the fabric of space itself, comes through with unusual clarity. The silence is precisely what allows you to hear. One of the signals astronomers search for in the voids is the imprint of what are called baryon acoustic oscillations. In the first several 100,000 years after the Big Bang, the universe was a plasma, a seething mixture of particles and radiation so hot and dense that light could not travel freely through it. Pressure waves moved through this plasma the way sound waves move through air, oscillating, expanding, compressing. And then, when the universe cooled enough for electrons to combine with protons and form neutral hydrogen, the plasma became transparent, the radiation streamed free, and the waves froze in place. They left their signature in the distribution of matter, a preferred clustering scale of roughly 500 million light-years, a faint but measurable tendency for galaxies to be separated by that distance rather than any other. This scale is present in the voids. It is written into the emptiness as surely as it is written into the matter. And because we know the physical origin of that scale with great precision, we can use it as a ruler, a standard against which to measure how much the universe has expanded since those waves were frozen, how the rate of that expansion has changed, what forces are driving it now. This is the strange alchemy of modern cosmology. You look at nothing, carefully, quantitatively, with instruments of remarkable sensitivity, and nothing tells you something. The void speaks if you know how to listen. And learning to listen is itself a kind of discipline, a practiced quieting of the expectation that meaning must arrive loudly, must announce itself, must come accompanied by the drama we have been conditioned to associate with discovery. The great revelations of cosmology tend to arrive as small numbers, as fractional shifts in a measured value, as a data point that sits slightly outside the predicted range and refuses, upon further examination, to move back inside it. They arrive quietly, and the voids, appropriately, are among the quietest sources of the loudest truths. Consider what it means that we can do this at all. That we can stand on a small rocky planet orbiting an unremarkable star on the outer edge of a middling spiral galaxy and reach outward with mathematics and light and recover the acoustic signature of pressure waves that moved through the primordial plasma more than 13 billion years ago. That we can use the shape of emptiness to measure the geometry of the cosmos. There is something in this that resists easy description. It is not simply impressive in the way that a large engineering project is impressive. It is philosophically vertiginous. It suggests that the universe, for all its indifference, for all the immensity of its silences, has left itself legible. That the laws governing a quantum fluctuation in the first moments of existence are the same laws that govern the distribution of superclusters today, and that both are accessible, in principle, to a mind patient enough and precise enough to look. Whether that legibility is a feature of the universe or a feature of the minds doing the reading is a question that does not resolve cleanly. Mathematics describes reality with an accuracy that has never been fully explained. The equations work. They work at scales far removed from those in which they were developed. They work in conditions no human has ever directly observed, in environments no instrument has ever directly sampled. Why they work is not a question physics can answer from within itself. It is a question that sits at the boundary between physics and philosophy, between description and understanding, and it has occupied some of the most careful thinkers in the history of science without arriving at a consensus. We do not know why the universe is mathematical. We only know, with considerable confidence, that it is. And the voids participate in this mystery as fully as anything else. Their growth is governed by equations. Their shapes encode information that those equations allow us to decode. The way light moves through them, bending slightly around the small concentrations of matter at their edges, leaving subtle patterns in the polarization of the cosmic microwave background, can be predicted and measured and compared. Every comparison is a test. Every test, so far, has returned a result that the framework can accommodate, though not always without tension, not always without the kind of small discrepancy that keeps theorists awake in the particular way that interesting problems do. There is a tension in modern cosmology that has been building for years now. It lives in a number called the Hubble constant, which describes the rate at which the universe is currently expanding. When you measure this rate using the early universe, using the cosmic microwave background and the acoustic oscillations frozen into it, you get one value. When you measure it using the late universe, using the distances to nearby galaxies and the behavior of a particular class of pulsating stars called Cepheid variables, you get a slightly different value. The difference is small in absolute terms. But it has persisted across multiple independent measurements, across different teams using different methods and different instruments, and it has not gone away. It may be a systematic error in one or both methods. It may be a sign that our standard model of cosmology is incomplete, that something in the early universe behaved differently than our equations predict, that dark energy is not a simple constant but something more dynamic, more variable, more alive in its behavior than we have assumed. The voids are implicated in this question. Their structure, their depth, the precise way they have grown over cosmic time, all of it bears on the expansion history that the Hubble tension is probing. They are not peripheral to the mystery. They are part of its texture. What is remarkable about this tension, this unresolved discrepancy sitting at the center of modern cosmology, is not that it exists but that it is possible to have it at all. That our measurements are precise enough, our models constrained enough, our understanding deep enough, that a difference of a few kilometers per second per megaparsec can be recognized as significant, can be taken seriously, can motivate new observations and new theoretical frameworks. The history of physics is littered with anomalies that turned out to be noise and anomalies that turned out to be doors. The Hubble tension may be either. But the fact that we are standing in front of it, examining it carefully, taking its measure, is itself a testament to how far the cartography of the cosmos has advanced. And still the voids expand. Indifferent to the debates being conducted about them in observatories and conference rooms and the pages of journals that will themselves eventually yellow and dissolve. The universe does not pause for its interpreters. It continues its patient elaboration, its slow unfolding across timescales that make the entire history of scientific inquiry look like a single breath drawn and released in an otherwise unbroken silence. A single data point in a record so long that even the light from the oldest observable galaxies represents only a chapter, only a passage, only a handful of lines in a document whose full length we cannot see from where we stand. And what we cannot see is, in some ways, the most important part of the story. Because the observable universe, that sphere of space from which light has had time to reach us in the roughly 13 billion years since the cosmos became transparent, is almost certainly not the whole of it. The universe almost certainly extends beyond what we can observe, possibly by a vast margin, possibly without limit. The regions beyond our cosmic horizon are not inaccessible because of any failure of our instruments. They are inaccessible because of the structure of spacetime itself. Light from those regions has not had time to reach us. In an expanding universe, some of it never will. There are galaxies, perhaps billions upon billions of them, that exist in a permanent and absolute sense beyond our ability to detect, to measure, to know. They are as real as anything in our observable volume. They simply cannot speak to us across the distance that separates us, because the distance itself is growing faster than the message can travel. This is one of the lonelier implications of modern cosmology. That the universe we can see, as vast as it is as overwhelming as it becomes when you sit with its true dimensions for long enough, is almost certainly a small and perhaps vanishingly small fraction of the whole. That most of what exists is fundamentally unreachable, not in the practical sense of being very far away, but in the absolute sense of being beyond any possible communication. And the voids, in our observable volume, are already so large as to strain the imagination. What lies in the unobservable regions we cannot say with certainty, but there is no physical reason to expect the large-scale structure to terminate at our horizon. The cosmic web, in all likelihood, continues. The filaments extend. The voids persist. The emptiness goes on in directions we will never be able to name. There is a philosophical position, held by some cosmologists and by a larger number of people who think carefully about these things late at night, that the universe's indifference to being observed is itself a kind of information. That a cosmos which extends beyond all possible observation, which contains structures and events and perhaps forms of complexity that will never be known by any mind anywhere, is telling us something about the relationship between existence and awareness. Most of what exists does not require a witness. Most of reality proceeds without acknowledgement, without record, without the small local ceremony of being noticed. The voids have been growing for billions of years in regions of space that contain nothing capable of observing them. They will continue to grow for billions of years after the last complex structures in our observable universe have dissolved back into the cooling, thinning dark. Existence, the universe seems to suggest with considerable patience, is not contingent on being perceived. And yet here we are, perceiving. Here, on this particular arrangement of rock and water and atmosphere, in this particular corner of one particular galaxy among hundreds of billions, something happened that the universe apparently does not require and did not guarantee. Complexity organized itself to a degree sufficient for self-reflection. Matter became curious about matter. The cosmos developed, locally, temporarily, a way of looking at itself. And what it sees, when it looks outward from this improbable vantage point, is the dark, is the web, is the filaments and the voids and the vast unhurried expansion of everything away from everything else. It sees its own loneliness, if loneliness is not too small a word for something operating at these scales. The nearest large void to our own location in the cosmic web is a structure sometimes called the local void, a region of below-average density that our own local group of galaxies sits on the edge of, being gently pushed away from by the slightly higher pressure of the matter distribution within it. We are, in a quiet and technical sense, void-adjacent. The emptiness is not something that exists only at cosmological distances, only in the abstract regions charted by redshift surveys. It is our immediate neighbor. It has been influencing our trajectory through space, contributing to the peculiar velocity of our galaxy relative to the smooth Hubble flow for billions of years. The void is not out there, in some separate region of concern. It is here, pressing softly against the edges of the structure we inhabit, a constant and largely unnoticed presence in the local geography of space. There is something quieting about this, if you let it be. The void is not a threat. It is not waiting to consume or to diminish. It is simply there, as it has always been, doing what empty space does, which is to expand, and to persist, and to hold its silence with a patience that nothing else in the universe can match. It does not need to be understood to be real. It does not need to be named to continue its slow elaboration across the fabric of what is. And perhaps that is the deepest thing the voids teach, if teaching is a word we can apply to something so entirely without intention. That presence does not require recognition. That existence does not require an audience. That the most fundamental things in the universe, space, time, the slow drift of matter under gravity, the quiet deepening of the voids, proceed with complete serenity whether or not there is anything present to register them. And this, strangely, is not a diminishing thought. It does not make the act of noticing feel futile. If anything, it makes it feel more precious, more contingent, more worthy of the attention we are able, briefly, to give it. Because we are brief. This is something cosmology makes difficult to avoid, not as a morbid fixation but as a simple geometric fact. The universe is approximately 13.8 billion years old. Complex life on this planet has existed for a fraction of that. Technological civilization, the kind capable of building telescopes and writing equations and measuring the shapes of voids, has existed for an eye blink so small that no astronomical unit of time can express it without rounding it away entirely. And the future, if current physics is correct, dwarfs even the past by margins that defeat ordinary language. The era of stars, the period in which the universe contains enough density and temperature gradients to sustain nuclear fusion, is expected to last for something in the range of 100 trillion years. After that comes a longer darkness, a slow cooling, a gradual unwinding of the remaining structures as black holes evaporate and protons decay, and the last faint embers of organized complexity release their energy into an environment that has become too cold and too diffuse to use it for anything at all. The voids will still be there. Larger, emptier, colder, expanding still into whatever it means for space to expand when there is almost nothing left within it to mark the expansion by. We exist, in other words, in an extraordinarily early moment. The universe is not old, not by the measure of its own future duration. We are among the first inhabitants of a cosmos that has barely begun. The stars burning now, the galaxies spiraling and colliding and forming new suns in their compressed gas clouds, the large-scale structure still assembling itself under the influence of gravity and dark energy. All of this is the dawn. And we are creatures of the dawn, awake before most of the universe's history has happened, looking out at a sky that is, by the standards of deep cosmic time, still crowded, still luminous, still relatively warm. There is a concept sometimes called the stelliferous era, this current epoch of star formation and stellar burning, and we are inside it, near its beginning. Future observers, if any exist in the universe's middle or late periods, will look out at a sky far darker than ours. The galaxies will have drifted beyond each other's observable horizons, carried apart by the expansion. The stars that remain will be dim, long-lived red dwarfs burning their hydrogen with extraordinary frugality over timescales of trillions of years. The cosmic web, the filaments and voids we have been tracing tonight, will have been stretched and thinned almost beyond recognition. The universe will be quieter even than it is now. And it is already so quiet that the quietness is one of the primary facts about it. What do we do with this knowledge? What does it mean for the way we move through our days, the way we hold our concerns, the way we apportion our attention and our care? Cosmology is sometimes accused of inducing a kind of paralysis, a sense that nothing matters because everything is so large and so indifferent. But this has never seemed quite right. The argument that scale negates meaning requires a premise that meaning is somehow proportional to size, that a small thing in a large universe is less significant than a small thing in a small universe would be. And there is no obvious reason to accept that premise. Meaning, to whatever extent it exists, seems to be a local phenomenon. It arises in the relationship between things that are capable of valuing and things that are valued. It does not require the universe's endorsement. It does not become less real because the universe contains voids. The voids, in fact, may be part of what makes the local possible. A universe without them, a universe of uniform density, would have been a universe in which structure could not form, in which gravity had nothing to work with, in which the differentiation required for stars and planets and the long patient chemistry of biology could never have gotten started. The emptiness is not incidental to our existence. It is, in a deep structural sense, a precondition for it. We are here, in part, because the universe contains places where almost nothing is. The nothing made room for the something. The voids cleared the way. And so we find ourselves at a kind of threshold, not the end of the inquiry, but a particular vantage point along it, a place where the path behind is visible in some detail, and the path ahead dissolves into a darkness that is not threatening but simply honest. We have traveled, tonight, through scales of space and time that the mind cannot fully hold, only approximate, only gesture toward. We have looked at emptiness and found it structured. We have measured silence and heard within it the acoustic memory of the universe's first moments. We have followed the logic of the voids from their quantum origins to their present dominance of the cosmic volume, and we have found that at every step the story opens rather than closes. That every answer is a corridor leading to a larger room. That the universe, examined carefully and honestly, does not resolve into simplicity but deepens into a complexity so fundamental, so layered, so patient in its unfolding, that the appropriate response is not frustration but a kind of settled wonder. A wonder that does not demand resolution. A wonder that is comfortable, finally, with not knowing everything, because the not knowing is itself a form of contact with the real. The voids will continue their expansion long after the last paper has been written about them. Long after the last telescope has gone cold and the last observatory has been swallowed by geological time, and the civilizations that built these instruments have become as remote from whatever comes next as the first single-celled organisms are from us. The voids do not require our attention to grow. They do not need our equations to be true. They existed before we named them, and they will persist long after the names have dissolved with everything else into the general silence. And yet the naming mattered. The measuring mattered. The long patient work of trying to understand what the universe is and how it came to be this way and where it is going, this work mattered, not because it changed the voids, but because it changed us. Because it produced, in the minds that undertook it, a quality of attention that is among the rarest and most valuable things this planet has ever generated. A willingness to look at something vast and difficult and not look away. A capacity for sustained wonder in the presence of the genuinely unknown. This is what the dark between the galaxies offers, if you are willing to receive it. Not comfort in the conventional sense. Not reassurance that the universe is friendly or purposeful or organized around human concerns. But something that functions like comfort anyway, something that arrives through a different door. The recognition that you are part of something that has been unfolding for 13 billion years and will continue unfolding for longer than any number you can hold in your mind. That the atoms in your body were forged in stellar interiors and scattered by stellar deaths and gathered again by the slow patient work of gravity into this temporary, improbable, luminous arrangement that is capable of lying here in the dark and thinking about voids. That the same physics governing the growth of the largest structures in the observable universe is governing the electrical signals moving through your mind right now as these words arrive and settle and perhaps mean something, or perhaps simply pass through like light through an empty region of space, leaving the faintest trace. There is a version of sleep that cosmology makes possible, if you let it. Not the sleep of exhaustion or escape, but the sleep of having been genuinely located. Of knowing, in a way that goes below the verbal and into something more physical, more cellular, where you actually are. You are on a planet. The planet is moving. The solar system carrying it is moving. The galaxy containing the solar system is moving, drawn toward the great attractor, pushed gently by the local void, woven into the filaments of the cosmic web in a position that took the entire history of the universe to produce. And around all of this, in every direction, at distances that increase with every passing moment, the voids continue their silent work. Expanding, deepening, growing more empty as time draws matter toward the filaments and the clusters, as gravity and dark energy continue their long unhurried negotiation over the fate of everything. You do not need to hold all of this. You do not need to understand it completely or carry it with you into sleep as a weight. You can let it do what the night sky has always done for those who are willing to look at it without flinching. You can let it put your ordinary concerns into a proportion that is not dismissive of them but is gently, accurately larger than them. Your worries are real. Your life is real. The people you love are real. And they exist inside a universe that is almost unimaginably old and large and dark, and that darkness, properly understood, is not hostile. It is simply the canvas. The voids are not empty of meaning. They are empty of distraction. They are the silence that makes it possible to hear anything at all. So let the expansion continue. Let the filaments hold their galaxies like dew on a web that no one wove. Let the supervoids deepen in the night that has no night, the dark that has no darker edge to find. Let the cosmic microwave background cool its final fractions of a degree over the next billions of years, that ancient light still traveling, still carrying the memory of sound in a universe too young to have silence. Let all of it proceed as it has always proceeded, with the unhurried certainty of physics, with the indifference that is not unkindness but simply scale. And let yourself be still inside it, small and brief and warm and conscious, aware for this moment of the voids, aware of the distances, aware of the expansion carrying everything outward into a darkness that has no end we can see from here. And then, gently, let even the awareness go. Let the knowing soften into something quieter. Let the questions rest. The universe will still be there in the morning. The voids will still be growing. And you will have slept inside the largest thing there is, cradled in the dark between the stars, held by the same gravity that holds the galaxies, breathing in the same silence that the cosmos has been breathing since before there was anything to know it was.